Hi everyone, welcome to the new video. So today we will understand about on-prem to cloud. Like when any organization decide that we will migrate from on-prem to cloud, then what all is taken in mind, what all is analyzed, and how we should start. So yeah, let's go. So, to understand this topic, first we need to understand that why there is a shift from on-prem to cloud. So, on-prem characteristics are that we will have our own hardware. It is hardware-bound compute, and we will have to manage the hardware too. We will have the static IPs and static routing that it won't be changed. The IPs won't be changed. Everything will be static. Manual provisioning every time whenever there is a new request. There is no automation. You have to manually provision. Vertical scaling. So vertical scaling is increasing the size, or when there is a heavy load you need to itself create a new server. So that is to handle the heavy load on your application. You are you know increasing the server, or what you say, size, or uh, so basically a new server is itself required. So monolithic deployment patterns. So patterns of deployments are monolithic, like it's not automated. Management through ITIL processes, those are old processes. Now when we see about cloud, we have ephemeral compute. Like, we can use it till the time we need it, and if we don't want, we can of course dump it. Dynamic IPs and service discovery. Automated and declarative provisioning. We can of course have use IAC tools to do the provisioning. Horizontal scaling, that if you till the time you need, because when there is a heavy load you use that. When there is no heavy load you can uh, destroy it. Microservices and event driven patterns. Okay. DevOps and GitOps for change propagation. So this is what why there is a shift is happening from on-prem to cloud. And then the key theory is that cloud infrastructure is immutable, dynamic, and API driven. Traditional on-prem environments are mutable and stateful. Stateful means uh, every state, every data is stored. It's not destroyed. But in cloud, for us, data is stateless. It's not static. So when we are shifting, when we are transitioning from on-prem to cloud, we have to make sure, like, how what is the landing zone. Proper cloud foundation requires a landing zone. Now, what you'll be confused that what is a landing zone. So landing zone means that how you are going to create these scalable multi-account or multi-subscription architecture that enforces security and governance before workloads arrive. So before you are migrating your servers, uh, your infrastructure to cloud, how it will be the designing of architecture, like what like in Azure we have multiple subscriptions, in AWS we have multiple accounts. So how are you going to design it, how everything will look like, how everything will be able to sign into it, and what is the security measures that you are going to apply. After this is a very basic thing that should be designed first, and then we should proceed. Like network fabric design, like hub and spoke or transit gateway, private versus public subnets, what subnets we are going to use, VNet pairing or VPC pairing, like when there are multiple virtual private cloud. So how the communication will happen from another VPC to another VPC, on-prem hybrid connectivity with IPsec or direct connect express route. So how that connectivity will be established, because sometimes you will be on hybrid mode, you are not um, migrating all the things at once. So everything should be decided. A landing zone, okay, this is how we are going to do. The security baseline, like federated identity, how logins will happen, how the role based and attributes based access model, key vault integration, zero trust access pattern, then logging and observability backbone, then everything because this is something, these the characteristics of cloud we should use. We should use logging, we should use the identity management that we have, and the isolation that we have by creating multiple names, multiple accounts. Under multiple accounts they will have their namespace, own resources. So these all things we will be able to get in cloud. In logging observability backbone, how we will do log inspection using ELK, CloudWatch, GCP logging, matrices, time series monitoring, tracing, open telemetry pipeline. Every, the matrices, like if you want to know the CPU usage at specific time, you can get that out. If you want to trace any error, you can do that as well. Governance framework, like how the networking, how will be the cost security happening, what will be the code policy code, um, okay, what rule should be allowed, what rule should not be allowed. So how those policies will be maintained, at what level it should be maintained, so at organization level or at specific resource level, that governance framework should be designed. So this is how, once the landing zone is prepared, we are good to go to move the resources. Now, migration theory is, there are six migration strategy. Rehost means whatever VM for VM lift and shift. Like if there is a VM on on-prem virtual machine, similar same thing we are creating in cloud also. Replatform means minimal modifications, like we, instead of VM we have dockerized uh, that application, it was not dockerized, so minimal modifications. Refactor means rewrite for cloud native patterns, like you're totally changing. Earlier it was something else, it was a micro monolithic, now you're changing to microservice. Repurchase, move to SaaS, software as a service, like you completely disposed your on-prem application and you start using a SaaS. Retain, keep on-prem, okay, retire, decommission, obsolete services. So these are the migration theory. Like some things you want only retain means that some things will be, you want that you will be keeping in on-prem only, you won't be migrating. So that is your, this is one strategy. Or retire means if something you don't want, you decommission it. So cloud modernization maturity level, like legacy on-prem, manual operation, hybrid lift and basic VMs in cloud. Cloud optimized, we have containers, we have managed DBs, databases. Cloud native, like microservices, serverless, service machine, service mesh. Self-healing and autonomous architecture infrastructure, like we now believe in decoupling architecture, like everything decoupled, not tightly coupled, so that if anything is wrong, whole application will go down. Instead, if something is not working, some piece, we can work on it instead of the whole application going down. So instead of tightly coupling the architecture, we should use the little less coupled architecture. Now we DevOps technical pattern, like when in cloud, when we shift to DevOps, like how we infrastructure as a code will be, then what we can use, then what the CI/CD pipelines we can use, if it will be a GitOps model, what will be the branching model, what how will we doing the deployments, like blue green canary feature flag, automated unit integration, how the testing will be. Then if we are going for containerized pattern, then how we are going to um, we are having the multi-stage Docker builds, image scanning we are going to do, then 6 to signing those images to perform the security. Then the Kubernetes and orchestration, how that that also we should. So this all comes in DevOps. In cloud, these comes in DevOps, like control, declarative reconciliation, operator and CRD, service mesh, auto scaling types. So DevOps is not about tools; it's about declarativity, immutability, automation, and observability. So SRE and cloud reliability engineer. So after that, we have the SRE thing that comes into scope, that how much our application or how it is performing, every logging is being traced. We are chaos engineering, in which injection of failure to validate resilience. We have tools for this. We have auto healing patterns, so we can even do automations if anything is down, if pod is going down and we know the pattern, we can automatically write script to heal that, to capture that event and trigger the script for that. We have disaster recovery, okay, if uh, for that we have RPO theory. So reliability is an engineering discipline, not a configuration setting. We have to always be testing this, because we won't be ever complete that we have done everything and our application is fully reliable. We don't know what can come. So cost engineering comes in mind when we deal with cloud, that how right size compute or server should be used, how spot instances should be used, how saving plans and reserve instances. Then FinOps practice comes in play. So with on-prem to cloud transition, all these things comes into picture, that how so we talked about first of all the cloud engineer, who mainly maintain, or who mainly deal on the things on cloud. Then we saw DevOps play. Then we saw how SRE came into picture, and then we saw how the cost engineering came into picture. So with the on-prem, I'm giving the not only the roadmap, but also what all things come into picture when we migrate. It's not like these are not there in on-prem. Of course, it's there, but when there is a shift, so much shift, we should understand that as well. Then I have an architecture diagram also for AWS, for Azure and GCP. I'm going to share this repo link in description box so that it's very easy for you to understand. You can go through these architecture diagram, that from on-prem, how we are doing VPN, how the service that we can use to connect to AWS cloud. Then there are the shared services, landing zone, how public setnet, private subnet resides in VPC, and what DevOps has been doing. Then we have services for DevOps too. Then comes into picture Azure. You can go through the architecture diagram of Azure too, and then we have for GCP too. So of course you can go through this. I'll share the repo link in the description.
So that's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.